Sir Isaac Newton is renowned for his groundbreaking work on the laws of motion and universal gravitation. Newton's interpretation of gravity is encapsulated in his law of universal gravitation, which he detailed in his monumental work, Philosophiae Naturalis Principia Mathematica, Mathematical. Newton's law of universal gravitation states: force of gravity. Every point mass in the universe attracts every other point mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance. The force acts along the line joining the centers of the masses. Inertia and motion. Newton's laws of motion, particularly the first law, law of inertia, contribute to the understanding of gravity. An object at rest stays at rest, and an object in motion continues in motion with the same speed and in the same direction unless acted on by an external force. Gravity, in Newton's view, is the force responsible for the attraction between masses, influencing their motion. Equal action and reaction. Newton's third law of motion, action and reaction, implies that if object A exerts a gravitational force on object B, then object B simultaneously exerts an equal and opposite force on object A. Mass and inertia. Newton introduced the concept of mass as a measure of the amount of matter in an object. The greater the mass, the greater the force of gravity it experiences. This understanding ties into his laws of motion, emphasizing that massive objects require more force to accelerate or decelerate. Kepler's laws. Newton's work built upon Johannes Kepler's laws of planetary motion, providing a theoretical explanation for the observed patterns of planetary orbits. Newton demonstrated that Kepler's laws could be derived from his own laws of motion and gravitation. Newton's interpretation of gravity transformed our understanding of the physical world. His laws of motion and the law of universal gravitation laid the foundation for classical mechanics and became the dominant framework for understanding motion and celestial mechanics for centuries. While Albert Einstein's theories of relativity later refined our understanding of gravity in extreme conditions, Newton's work remains a cornerstone of classical physics.